then you don't have to do very much. You might have to do a couple of properties, or you might have to rewrite. But if you already have log on both sides, then you just keep going with your properties. And the properties for this one, does anybody know which one it is? Which property fits this one? Well, what does each side have in common? The same what? Same base, Hubert. That's right. If you have two logarithms with the same base, what can you do with the equation? Set them what? Set them equal to each other. And solve. Okay. So that's going to be 2x I think people have lost their damn minds. I'm talking to my TV. My TV in the den is talking about no COVID, no Thanksgiving, nobody have Thanksgiving. I think people have lost their damn minds. -3, -3, 2x is equal to 6, x is equal to 3. There you go. So, what can we learn from this one? Well, we started off with log on both sides. When you have log of both sides already given, then your chances are pretty much, your choices are to rewrite. Okay, because you've already got the log of both sides. One of the rules in solving an exponential is take the log of both sides. Well, if you already got the log of both sides, then you're going to have to do something different. And that usually means rewrite with the properties. And the property here is the same base. Okay, so let's go to another one. Maybe I can pull one of each kind. Let me see if I can find, okay, here's one. All right. So we've got log base 7 of x minus 2 plus log base 7 of x plus 3 is equal to log base 7 of 14. Okay, so if you've got this one in your notes, the first thing you're going to say is rewrite with properties, because the difference between this one and the previous problem is this one has two parts on the left-hand side. The first one did not. The first one just had one part on each side, one term, and one term. This one has two terms on the left side and one term on the right. So it's a totally different animal. So here we've got to rewrite with the product rule first. Because we do have the same basis, so that means we can use our properties. But we can't just set equal yet, because we've got to rewrite. because we've got 2 on the left and 1 on the right. So that's going to be log base 7 of x minus 2 times x plus 3 is equal to log base 7 of 14. Now, we've got 1 term on the left, 1 log on the left, and we've got 1 log on the right. Now what can we do? That's when I want y'all to say something. That means I want y'all to say something.
Set them equal to each other.
Thank you, Mr. Cash. I'm sorry it's always you. But yes, set equal to each other. All right, finish it. And using the FOIL, x squared, 3x minus 2x is x, minus what? 6 is equal to 14. And if you want to bring that 14 over, it's going to be a negative 14. So x squared plus x minus 420 is equal to 14. Parentheses, parentheses, x and x, 4 and 5 has to be a large number with positive, unlike with the negative, equals 0. So our answers are 4 or negative 5. Now we've got to check this because that negative, this negative right here could blow up the function. Let's see. What is negative 5 minus 2? Boom, it blows up. What is negative 5 plus 3? Boom, it blows up. So what do we do with the negative 5? Put a big AX through it because you can't use it. So your answer is FO. FO, FO. So far, these are 2 good test questions. Next question. Right quick. I'm just going to see. No hurt in trying. Uh-oh. Looks like they fixed it. I'm just going to go to the homework. .4. Where's the equations? Is 6.4 solving equations or 6.5?
6.5 is solving equations.
Oh, thank you. I get y'all mixed up with the 109. 5.4 is solving equations and there's 6.5. Okay, here's one. Solve the exponential. This is what I was looking for because I've already showed you 2 logarithms. Now I'm going to show you how to solve this one. This is an exponential. So 4 times 1.23x is plus 2 is equal to 9. So, what the hell are we supposed to do? Well, treat this like a pre-algebra problem. 4x plus 2 is equal to 9. What do you do first? What do you do first on that pre-algebra problem? Okay, Mr. Bates is here, so everybody congratulate Mr. Bates. He's here today. Welcome to the class, Mr. Bates. And nobody's going to say anything.
Subtract 2 from both sides.
Subtract 2 from both sides. Thank you, Mr. Cash. Looks like these weaned on pickles will get tired of me asking questions and just answer. Equals 7. But that's why they're going to have closet offices. Probably going to get beat up by their boss, too. 7 over 4. Okay, so that's how you do that problem. So do it over here. Minus 2. 4 times 1.23 to the x power is equal to 7. Divide by 4. And you got 1.23 to the x power is equal to 7/4. Now you don't have a logarithm, you've got an exponential, and you can use definition of what? You can use the definition of a logarithm, Hubert. That's right, class. Good job. You've got a to the y is equal to x. Let's go over the definition of a logarithm. Definition of a logarithm is y is equal to log base a of x yields a to the y is equal to x. Well, a is equal to 1.23. Y is equal to x. And x is equal to 7/4. Plug and chug. X is equal to log base 123 of 7/4. And the change base formula says that if I want to punch this in a calculator, I do log of 7/4 divided by the log of 1.23. And let's take our handy dandy calculator and clear log of 7 divided by 4, close parentheses, divided by log of 1.23, and enter. 2.70327 blah blah blah. 2.703272871. Anybody got a question on that one? So let's go to the question and type in it says round Okay, I don't see any. Okay, that's to the hundredths. 1.23 is to the hundredths. So we're going to round to the hundredths. 2.70. Uh-oh. Let's see what they got. Okay, whatever. Somebody take 1.75, log of 1.75 over the log of 1.23. And see if you don't get 2.7. Somebody check that right quick for me.
Yeah, I got 2.7.
Okay. So that's a homework question. What? Okay. So maybe now they want the answer. Round to the nearest thousand. Okay. Now they want the answer. 2.703. There we go. So that's a good test question. Now that's an exponential. There's two types, an exponential and a logarithm. We've done two logarithms. First logarithm, second logarithm, and this is an exponential. Now some exponentials, there's two types of exponentials. There's some exponential equations you can do the definition of a logarithm. And then there's other equations that you have to take a log of both sides. See if I can find one for you. That's the definition of a logarithm also. Definition of a logarithm. Okay, okay. All right, that one is properties of logarithm using the property. Let's do that one because that one is natural log and some of y'all might freak out because of that. Natural log of x plus the natural log of x squared is equal to 5. So use our property rules, and I'm going to highlight that positive. This positive right here tells you product rule. Now, could you change this to log base c of x plus log base c of x squared is equal to 5? You sure could. There's nothing wrong with writing natural log as log base c. If you like working with log, then there's no problem with it. Either way, you're going to get the same thing. Natural log of x times x squared is equal to 5. Natural log of x cubed is equal to 5. And that right there is the definition of a logarithm. And you can you can say log base c of x to the third is equal to 5. So log base a of x is equal to y. So y is equal to, I'm sorry, I just messed that up. Let's write down the definition of a logarithm. Y is equal to log base a of x. And that yields a to the y is equal to x. So a is e, y is 5, is equal to x to the third. And how do you undo a cube root? I just told you. How do you undo a cube? Told you the answer and you still won't tell me. Anybody but Mr. Cash. How do you undo a cube? How do you undo a cube? I'm waiting because I don't think that there's 9 algebra students, college algebra students in this classroom that don't know how to undo a cube. That's not possible.
Take the cube root.
Thank you, Mr. Malota. Thank you. You take the cube root. So x is equal to the cube root of e to the 5th. And I'm going to do that on the calculator. I'm going to raise e to the 5th to the 1/3 power. And that's going to be e to the 5/3. Because I don't like fooling a radical. That's the calculus teacher in me coming out. So take your handy dandy calculator, and that's going to be second e parentheses 5 divided by 3, and e to the 5/3 is equal to 5.294. So they want the actual cube root. I'm going to write e to the 5/3 to see if they like it. E exponent 5/3. Oh, wow, it took it. That's it. Okay, that's another properties. That's another product rule. I'm trying to find the one that you have to take the log of both sides, and I hadn't found it yet. That one you square both sides. Let's write that one down. Square root of log x minus 1 is equal to log of x minus 1. And I said square both sides. Why? Somebody tell me what tells me to square both sides. Besides Mr. Cash. No offense, Mr. Cash. You're supposed to say none taken. That's all right.
None taken.
Thank you. All right. What tells me that I need to square both sides?
Because there's a square root, so you got to do it to both sides.
You want to get rid of the radical. You want to get rid of the radical. So I'm going to square both sides. Oh God, that's going to give me shortcut number 2 on the right, which some of y'all really suck at, still suck at. So you might as well just quit this problem. So that's going to be log of x minus 1 is equal to log squared x minus 2 log x plus 1. Well, that's not going to help nothing. Well, it might, because what we can do is we can bring this log over, and that would be minus log, and bring this over, be a plus 1, and we've got 0 is equal to log squared x minus 3 logx plus 2. And we can break that up into 0 is equal to log of x, log of x, and that's going to be a 1 and a 2, and that's going to be a negative 1 and a negative 2. So 0 is equal to log of x minus 1. 0 is equal to log of x minus 2. And bring this over, 1 is equal to log of x. And 2 is equal to log of x. And that's 10, and that's 10. And now you use the definition of a logarithm. And I'll rewrite that because hopefully you are seeing how important the definition of a logarithm is. Y is equal to log base A of x yields A to the Y is equal to x. We've got 1, Y is equal to 1, Y is equal to 2. We've got A is equal to 10. A is equal to 10. And Y, we'll see, Y is 1, Y is 2, and X is equal to X. So this one is going to come out to be 10 to the 1 is equal to X. And this one's going to be 10 to the 2 is equal to X. And X is equal to 10, and X is equal to 100. So let's check that one. And it says use commas to separate. We read from left to right. So 10 would come first, comma, 100. It's a miracle. Does anybody have a question on that one? I'll leave that one there for you. Because, like I said, when it comes to shortcuts, students suck at some shortcuts because they wasn't taught or they refuse to learn the shortcuts in high school. And that's shortcut number 2. And I'll write that in pink. Shortcut number 2. Y'all remember at the beginning of the semester, I told y'all that if you didn't learn shortcut number 1 through 3 or 1 through 5, that you were going to be sucking wind all semester. Well, that's true. And you're going to be sucking wind to your last math course, whatever that may be, if you don't learn those shortcuts. And that gives you that right there. I'm going to leave that up for a few seconds. So I wasn't expecting taking the square of both sides, but that's good that we've covered it. Because basically I'm trying to cover all the different types of solving. There's only one left, and that's the taking the square of both sides, and I'm still trying to find it. I just wish I could make up one, but I can't. I'm not that smart. I'm not like Rain Man. Let's see if I can find one. Nope. Nope. That's a shortcut. That's simplify. There's one. Wait a minute. Let me do it in my head. Log of x squared. That looks like one you would do. I don't know. Let's see. X squared equals 1.6 to the x power. Log of x squared equals log of 1.6x. Using the power rule, you get 2 log of x. That log of x bothers me. Equals x log of 1.6. And see, that's not really going to help because we've got x here and x here. That's not going to help. You might have to do that one with definition of a logarithm, which that would be a to the y is equal to x yields y is equal to log base a of x. And your a is 1.6. And your x is x squared. I don't know. And your y is x. I don't know. I still think you're gonna. Let me look at see this one. This one you might have to. Let's see if they take the log of both sides. No, they just set it equal to 0. Okay, that was my next thing that we were going to do. And this graph, they're just graphing it. They're not going to solve it. So, oh, I didn't see that. I'm still looking for one. That's all graphing calculator. So let me go back to the beginning. I'm just trying to find one more. They might have put them at the beginning. Nope. Nope. That's definition of a logarithm. This one may be it. Yeah. This one may be it. Let's see if we can do this one. I think this one is taking the log of both sides. Let's see if they do that. Yep. So here I found the last one. This is the one that you take the log of both sides. 2 to the x minus 6 is equal to 3 to the 2x. Now, what tells you that is all that stuff in the exponents. Got a lot of stuff in the exponents, and they're not the same, and the bases are not the same. If the bases were the same, if this was 3 to the x minus 6 and 3 to the 2x, then you could set them equal to each other. But since the bases are not the same, and you've got a lot of stuff up here and a lot of stuff up here, you're going to take the log of both sides. And use the power rule. Bring those out. X minus 6 times the log of 2 equals 2x times log of 3. Now somebody tell me what the log of 2 is and what the log of 3 is. I told you this at the beginning of the LOG section. What are those two things?
They're like normal numbers.
They're just numbers. So write that down. I'm going to highlight those in green. Now, the reason I'm highlighting them in green is because if you think about it, they could make the problem easier. Why? Because if you turn these into two numbers, then do you have a logarithmic problem or a pre-algebra problem?
Pre-algebra.
You have a pre-algebra problem. I still appreciate you, Mr. Cash. I'm just sorry you have to be the spokesman for the Weaned on Pickles group. So log of 2. That's all right. It's going to pay off, Mr. Cash and Mr. Mulata. Y'all going to have nice offices one day. Log of 2. Okay, now if you want to, I'm going to store that. How am I going to store that? Well, I'm going to stow it. That's where you go get bread at the stove. Right here, stove. I'm going to stow that. I'm just going to call it A. Alpha A. And I'm going to put in my little, I'm going to put A right there. And I'm going to take the log of 3 and I'm going to stow it. LOG of 3. And I'm going to stow that as alpha B. Okay, now I'm going to distribute A, and I'm going to distribute B. So A times X minus A times 6 is equal to B times 2 times X. I'm going to have to make this small. I can't get everything on one page, so I'm sorry. Okay, now I'm going to find out what A times 6 is. So I'm going to take my calculator and I'm going to go alpha A times 6. And I'm going to call that, you can write it down or you can round it. I'm going to round it to 1.8062. 1.8062. And I'm going to multiply B times 2 times 2. So alpha B times 2. 0.9542. And A is, we said A was equal to, what is A equal to? Alpha A is equal 0.3010, so 0.301x. So there is my pre-algebra problem. And of course, I'm going to divide or bring this over here, minus 0.3010x. And that's going to give me negative 1.8062 is equal to, well, that's going to be 0.9542 minus 30.3010 0.6532x. And divide both sides by 0.6532. So negative 1.8062 divided by second answer, which is the 0.6532, negative 1.6629. And that should be your answer if they want it in that form. And let's go to the question. And that's going to be negative 1.6629. And they wanted an exact answer, so I don't know if they want the log or what. Let's see. They want 6 log of 2 divided by 6. Yeah, yeah. Okay, there it is. Negative 1.6629, which 1.663. Okay, well, I must have got the wrong answer. They got negative 2.7, so we'll have to do that one again Monday. Okay, we're running out of time today. We'll do that one again Monday. Somebody make a note, number 15. Mr. Cash, since you're the only one that'll talk to me, make a note that we need to do number 15 again. I've just got something wrong somewhere. I need to fix it. Okay, because they're both negative. So that tells me right there I'm very close, but evidently I've got an error somewhere. Okay, so I've shown you all the different types of equations now, so you should be good to go with 6.5. 6.6, I have no idea what 6.6 is. Let me look right quick. Probably practical application, but I'll look and see. Come on, you can do it. You can do it. Applications. So we'll probably look at a couple of those Monday, but I wouldn't worry about doing the homework for 6.6. I would worry about these two sections right here, 6.4 and 6.5. That's where 80% of your test is going to come from. Any questions? Okay, I'm not going to change the roll. I'm not going to take the roll because I can't change it. So if you get an email next week that says I'm not going to fool with emailing them because it's last week. All y'all got to worry about doing is finishing all your homework and tests and get that done. So that's what you need to be working on this weekend. Oh, did I just let the cat out of the bag? Oh my gosh, I let the cat out of the bag, didn't I? So if you got any incompletes, get them done. Anybody catch the surprise yet? Anybody know what the surprise is?
Could redo old stuff that we missed.
Exactly. I've opened up everything. So that way anybody that missed anything don't have that excuse come the last week of class. You're welcome. All right. Y'all have a good weekend. I'll see y'all Monday.
Thank you.
See ya. Thank you, Mr. Cash and Mr. Malota.